Yeah.
Oh,
Ranjani, you
sure.
ready?
Yes.
Yeah, sure.
Okay. So, a very pleasant afternoon to everyone gathered here. I am Madhumita, an application developer at VMware. I thank everyone for joining today's session on exploring the regional AI. It gives me immense pleasure to introduce the speakers of the day, Ramya Victor and Ranjani Swaminathan. Here is a quick introduction of the speakers. Ranjani Swaminathan is an engineering manager in VMware with 12 plus years of experience working across various management and costing solutions for vSphere. She has participated and won in various industry wide hackathons on blockchain and machine learning. Her team won the global VMware hackathon in 2019 for bot aider solution. She has been a speaker in external conferences like Zenob and Women Who Code Connect Asia 2019. She is a passionate about giving back to the community, and that's really awesome. She is one of the city directors of Women Who Code Bangalore chapter and leads the AI ML track of Women Who Code. She is a committee member in the AI track for GHC India for 5 years now. Welcome, Ranjani. Ramya Victor
You.
has 8 plus years of experience in the software industry in the domain of network and storage. She has a master's degree in software engineering and PG diploma in AI ML. She is a lead engineer for a file system functional team at VMware India R&D. She is an active innovator and has presented in various national and international conferences like Open Summit, Grace Hopper Conferences India, Women Who Code Connect Asia. She has won Global Borathon in VMware and other external hackathons as well. She actively presents sessions on AI ML, cloud and virtualization across different communities and colleges. She is the city director of Women Who Code Bangalore chapter, an international nonprofit dedicated to inspiring women to excel in technology careers. She is a GHCI committee member of AI ML track for the past 3 years. She leads the AI ML focus group in Women Who Code Bangalore chapter. She is passionate in dramatics and she is a voracious reader. Can't wait more, and the forum is all yours. Over to Ranjani and Ramya.
Thank you, Madhumita, for that warm introduction. Yeah, over to Ranjani. Ranjani will probably start it.
Yeah, you can just share the presentation.
So I'll just share it, Ranjani.
Yes.
Yeah.
While it comes up, hello
So,
all. Great to see the interest and enthusiasm with the participants for our day 2 of our Women Who Code Connect India 2021. Yeah, I'm able to see Ramya.
yeah, you're able to see? Cool.
Thank you. So there have been many takeaways from other sessions. Hope you all are enjoying it. And our session is one such where we try to provide some experience by getting you all started with regional NLP. That is why we have the topic as Praakrtik Bhaasha Prasanskaran, where you would have guessed that it is regional NLP to do with Hindi language. We will see how we can use our NLP packages and the code that is available to use it with Hindi language. Hope you all are familiar with what is done with English language. We all understand that is the assumption, but we can walk you through the basics of NLP also while we are undergoing this complete session. So this is to make you understand about the work that has already been done in the area of regional NLP and leverage them in some of your innovation and add up to areas where there are still scope for development. So that is the aim of this session. With that, we see that in our agenda we have an overview of NLP and about regional NLP. There are some 3 commonly used libraries in NLP named INLTK, Indic NLP, Stanza, which we will be taking you through with specific examples and some of the hands-on that you can try out parallelly, and about the upcoming models that are present in the industry and that can be leveraged for regional NLP. So with that, we start with what NLP is about. So as you see, NLP is the ability of software to interpret the intent and meaning of sentences delivered in a text or when it is delivered by a speaker. So it is mostly to do with the similar ability for making a software interpret the sentences and respond to it like a human would do. So whenever we have a set of knowledge that we have gained over time on the language, and we try to interpret whatever is said and respond back. Similar capability has to be given to software. That is the area of NLP. And why NLP? People may be questioning why humans can already do it. Why should there be a separate area in artificial intelligence to do natural language processing? So if you look at the amount of data that is flowing through today, it is humongous. We are still trying to name what the amount of data should be. We know tera, peta, millions, zillions, and what should be the next level. We are already there. So we don't even have a name for the amount of data. So the data is humongous, and deriving insights from the data available would be tedious and time consuming. Also error prone if it has to be done manually. So this section of artificial intelligence enables our software to understand and help us there, and provide responses also wherever possible. So we give a corpus of data through which the software learns, and then it helps us going forward. So that is the case of NLP, and you would be able to see an example here. So this is a chatbot example where this chatbot is asked a question and it responds with an answer. So let us look at the question. So the user has asked, what is the return policy? So this looks like a e-commerce site where customers can view products online, order them, and they get delivered to their home. So that is the new norm, which is already been prevailing. And the question is, what is the return policy? So this, as a human, you would understand that it is asking about the return policy for any product that has been purchased through the software, and what is it the user is expecting. So similarly, the software should understand what is being asked. So first listen to the question. The software listens to the question, understands the intent of the question, and try to look into or look up into its learnings and come up with an appropriate solution. So here the answer to it is that the product can be returned within 30 days of receipt. So look at how clear it has been. So from 30 days of receipt, and all those details are already given. So this is how the software has interpreted and has come up with a relevant answer also. This is NLP for us, right? So there are, thank you Ramya. So there are various abilities that can be achieved using NLP. So wherever there is huge data, NLP can draw some context out of the huge data as short key takeaways. For example, from the transcript of this talk, when you have the complete paragraph, you can use NLP and get only the key takeaways or synopsis of the talk and still make value out of it. That is a live example what NLP can be used for. And there are language translations that can be done. For example, you have a book and it is written in Chinese. You are really obsessed to read it. So there are ways where you can, if there is a e-version, you can use translators and still understand that book, and without losing any interesting facts mentioned in the book. So that is some example of language translations, and we can understand what the sentiment of a given text is. So whenever you buy a product, you look at reviews and you understand the sentiment, and then only make a move to even commit to buying a product. Similarly, companies also have various workforces that are focusing on understanding the sentiment for a given product and trying to make improvements in their products so that they can get better customer sentiments over it. So that can be, NLP can be used here, and of course answering the frequently asked questions. So we saw an example of generating text, right? The answer was generated by the chatbot. So this is another use case where another ability where you can generate text based on the question that has been asked, understanding of the questions. Can you move? Yeah, to the next slide. Thank you. So from this, no, the previous one. So with all these abilities, we can get NLP to work with various products like a recommender system, which gives recommendation to users like, you have bought this product and why don't you try this other product? Or people who have already viewed these products have also viewed other products. Why don't you try them? Such kind of recommendations can be provided. And voice assistance. So with the natural language processing, understanding the intent and generating sentences, these can be fed into voice assistants, and instead of showing a text, the voice assistant can even go one level above and talk to you, so that you don't have to be in front of the system to get the results. So that is one booming area where everybody gets up and asks Google to switch on the geyser even before they come out and save that 5 minutes of sleep time. So that is one other area where NLP helps. And email filtering. Email filtering is also one of the areas where you can detect spam from non-spam mails and focus only on them. Okay? That is also one of the use cases of NLP. And as I mentioned, sentiment analysis also, and there can be many more use cases that can be derived from all these basic abilities of natural language processing. So can we move to the next? Sure. So we say NLP. So what are some of the basic tasks that are involved in NLP? So that is something that we should start with. For implementing something, we should know what is actually being implemented, why is it being done, and the understanding of whether it would actually address the gap. So these are some of the basic steps that are available for that a human also would do to process the text that is given to the human being. So sentence segmentation. When you have a big paragraph, you start reading sentence by sentence and try to make meaning out of it. So that is sentence segmentation and sentence tokenization. And then understanding what words are being sent and understanding the intent of each words. So the first step for which would be word tokenization, cutting down into individual words. So for example, in English language, if sentence segmentation can be done with a symbol of full stop, and we can parse the text, and word tokenization can be done with the space character, and we can split the sentence into words. Then the next step is to feed it into the software. So we as a human being can understand English or Hindi or any language, but the computer understands only zeros and ones. So this is also one such step where we have to convert the text into embedding format which is understood by the system rather than providing English words. So that is the step for embedding the text. And then we remove unnecessary words, stop words like the, on, off, and all those things can be removed, without which also, of course, with the help of it, you can derive meaning, but individually they don't contribute to the sentence. So those are stop word removals. The next step is stemming and lemmatization. where you have to understand that there may be various tenses in which the same word with the same meaning can be told. For example, gave, give, given, and all those things are three forms of the same word give. The base word is give. So we should make the computer understand, or the software understand the meaning by removing unnecessary redundancies in the words that we have given. The next step is to find n-grams. So if there are two words which are coming together always, or in most of the cases, we try to remember them as a single entity. So for those cases, we should find n-grams. For example, machine learning are two separate words, but they come together in this speech, at least together. So we should make the software understand that machine and learning are two inseparable components of a single entity. Such is the task of finding n-grams. And then is, of course, the parts of speech tagging, where we should understand whether it is a noun or a verb or an adjective or an adverb, and all those parts of speech should be understood to get the meaning out of the sentence. And then is the dependency parsing. So for example, I say that the book I read yesterday was quite interesting. So the book was quite interesting, but in between that we have that I read yesterday. So there are chances of misinterpreting that yesterday was quite interesting. So there are these dependency parsing to understand what this interesting refers to. Does it refers to the book, or does it refer to the yesterday? So all these are understanding of these constitutes the dependency parsing. And we have named entity recognition. Wherever there are many entities which are present, the software should be able to recognize them. So these are some of the, for example, if I mention the book that I read yesterday was quite interesting and it had a lot of characters, what does that it refer to? So we should again map it to the book. And those are some of the processing that we should do when there are more sentences, how each sentence relates to the previous sentence, and what all are to be remembered for interpreting the meaning. So these are some of the basic steps in tasks that has to be done in NLP. So we will I will give it over to Ramya for speaking about the regional NLP and some of the libraries.
Thank you, Ranjan. That was a very good intro on what is NLP and what are the basic steps involved. So let's move on to our actual agenda today. So the regional NLP. So we all know that majority of the big breakthroughs and the state of art frameworks that is done in NLP is mostly done for English language, because that is the common universal language that most of us speak in, right? So then why is the need for regional language? So we all know that human beings, all of us, are so different and diverse, and each of us are from a different region. So each of us have our own language. So there's so much diversity in terms of the multilinguistic languages that we speak, right? So just for an example, if you look at the slide, if you just take the Indian subcontinent, right, it is comprised of so many countries that are surrounding the Indian Ocean, like
Hey Ramya, we don't seem to hear you. Ramya, are you able to hear? Hey Ramya. Hey Ramya, we are not able to hear you. There seems to be some technical glitch from Ramya's side. She's looking into it. No, Ramya, not yet. We were able to hear you well. I think she's rejoining. Are you able to hear us? Are you able to hear me? Are you able to hear me? Yeah, I think Ramya is joining back.
What about now?
Yes.
Yeah. Hey, sorry, folks. Sorry for the inconvenience. I mean, it's quite relevant with our today's topic, right? Being resilient. We are trying to be resilient with the glitches in the network. So, thanks for your patience. Ranjini, could you just tell me where I was lost? Were you able to hear me when I was talking about this?
No, Ramya, we were able to hear only when you talked about various languages and all.
Okay, sure. Let me just quickly resume. Yeah, I'll just share the screen. Okay, it's Chrome tab, and yeah, here you go. Can you see it? Can you see it? Yeah,
Yes.
sure. So as I said, right, I mean, if you just take Indian language itself, I mean, the Indian country itself, we have so many different languages and there's so much different dialects and so many different pronunciation for the languages. So because of that, right, there was a need to have this regional NLP so that we can try to have like NLP applications built around this vernacular languages. So when I say vernacular languages, these are the languages which is local to a specific region or a country. So, and why do you have to have NLP applications on this? So that people in those regions can use the technology better. And having said that, if you have some historical data written in those local languages, you can kind of have NLP applications to translate them and to infer more data so that that knowledge can be spread to people across the world and to preserve that heritage over a period of time. So that is the need which kind of gave birth for the regional NLP. So having said that, regional NLP is not just confined to our Indian languages, it is confined to a specific region. But today our focus will be on basically the Indian language NLP. So let me move on to the next slide. So where do we start with, right? When I'm talking about regional NLP, so if I'm talking about Indian language processing NLP, where do we start with? If that is the question, this is your answer. So we have basically three Python libraries that are handling most of the NLP processing for Indian languages. So as you can see in the slide, the three commonly used libraries that you should start exploring from today is INLTK. INLTK is nothing but the equivalent of NLTK package. If you people have prior experience working on NLP, right, you would have definitely used NLTK package. So that is basically used for processing on English languages. So INLTK is for the Indic language, that is the Indian origin languages. And another package is an Indic NLP library. So, and third package is the Stanford NLP. So it is also called as Stanza. So today, Ranjani and I will take you through all these three libraries and will also touch base upon one of the upcoming libraries, which is of very good interest that you could explore. So moving on to the first library that we would like to talk about is the Indic library. Let me go to that. Okay, so I will basically talk about Indic library and give you a little bit hands-on on how it happens. And then Ranjani will take you through on the Stanza library and the INLTK library. Okay. So what is this Indic NLP library? So the main purpose of Indic NLP library was it was developed to support the common text processing, like as Ranjani touch based, right? You have tokenization. In tokenization, you have word tokenization, sentence tokenization. Then you have a stemmatization, lemmatization. You have a lot of processing that we do, right? So you cannot just take the language as is and tell the computer to infer it and kind of give me the output, right? You have a lot of pre-processing steps to be done, right? So having said that, we are working with regional language, we need to have a lot of pre-processing done specific to the regional language that we are working with, right? So to do all that, we cannot use the existing pre-processing methods that have been well trained and developed for English language. We need to have the same equivalent pre-processing steps for the regional languages. For that, we are using these library packages which have been well tested for the set of regional languages, right? So what are the pre-processing steps that is offered by Indic NLP, right? So as you can see, I have listed few of the operations or the pre-processing steps supported by Indic library. So you need to note that all these operations are not provided for all the languages that are supported in Indic library. So say Indic library supports around 16 languages. In that, these steps are being supported for few of the languages, and for few of the languages it's still a work in progress. So it's a very good domain to invest in terms of research work. So first, if you look, you have text normalization. So whenever we are dealing with regional NLP, right, you need to normalize the text, because for example, if you take Kannada or Hindi, we have the way we write, right, we have a design which we give on the top, and we dirgha, it is called dirgha in Kannada. And a lot of things we do in Hindi also, we give a slash after writing car, right? We give a slash down. So that has a different pronunciation, right? So we have a lot of nuances in our regional languages. So those nuances have to be captured in the right way when we are processing it, right? So we need to normalize those things and get the language in a more adaptable format where we can use it for the pre-processing. So text normalization is basically handling with such nuances in your language, like the dirghas, and you when you connect two words, you get one single word, right? So how do you deal with those things? So those are the things. I think there is a issue again. And hey, Ranjani, can you hear me?
Yes,
Can you
Ramya.
hear me? Yeah,
Yes.
okay, I thought there was a glitch. So that is basically very important step in regional NLP when we are talking about. I'm audible, right, Ranjani? Yeah, cool. So the next one is the tokenization. Like how Ranjini said, right? When you take any big sentence in a language, it has to be broken down into smaller processable chunks, right? So if you take a sentence, the smallest processable chunk would be the words. So word tokenization. If you take a big document, the smallest processable chunk would be a sentence. So that is called sentence tokenization. Break a big document into individual sentences. So how it's done for regional language, we can check. And script conversion is another important thing. Like I have a Hindi statement, but I'm not much familiar with reading Hindi. I am much familiar reading in Kannada. How do I do it? So I can do the conversion of that. So indexation is another process where you kind of have the language in one specific format, like you have it in the script, right? And how do you convert it into a different script? Like for example, I want Hindi script to be written in Kannada, right? How do I do it? Is very similar to translation with a slight variation on how the internal process is being done. And then you have script information. If you want to know that you have a sentence and you want to know what is the origin of that script, right? You don't know the script, you can get that information also using the existing functionality. And then you have another interesting thing called romanization and transliteration. We will look at that in the demo. That would give you a good hands-on on what exactly it is. So let me quickly take you to this table. So this basically shows how many languages are being supported in Indic NLP, right? So if you basically see, our Indian language has been broadly divided from ages into two sectors, that is Indo-Aryan and Dravidian, right? So the same logic is being followed in the Indic NLP Python library. So they also have categorized the language into Indo-Aryan and Dravidian. So in that section, these are the basic languages that are being supported. And here are the different keywords to annotate for each of the languages. So as I said, right, each of the tasks being listed over here is not applicable for all languages because it's a work in progress still. So if you can see here, for example, script information is not available for an Urdu. So if you have an Urdu sentence and you're not aware that's an Urdu sentence and you want to know more information about it, that a particular call would not work for Urdu because that is not being implemented. So if you clearly look at this table, right, you can get to know what are the different text pre-processing steps that are applicable for the supported languages and which are still work in progress. So this is a very nice table if you are looking for research work to be done in this particular language, right? So yeah, this is where I wanted to touch base upon. So as I said, right, regional language is more of different pronunciations, right? And if you take one language itself, you just take Hindi also, there is so much slang difference across different state when we speak in Hindi. So all that nuances should be captured very well when we are doing speech processing, right? But when you look at the text processing also, the input that you get for text processing need not be always textual, right? As in, you could have a voice interpreter which will convert whatever you're talking in Hindi into the Hindi literature, right? So probably the input that your model gets is not the Hindi actually written, but it is a Hindi script that has been translated by a speech translator, right? So that time based on the user slang and all, the word pronunciation would be different and it would have been translated differently, right? So all those details also should have been accounted in our model. So That is one good area of research that has been very well handled in all these NLP packages that we are going to explore. So that is what has been highlighted in the place of articulation, right? When we tell k in Hindi and k, so from there exactly the sound comes, right? The phonetic sound comes. So all those information also you have a built-in library using which you can figure out how to figure out what is the right pronunciation of the word when you're processing the regional languages. And the other thing is you need to understand the difference between translation and transliteration. So we did tell that the NLP regional packages offer transliteration, right? So what exactly it means? So most of you know, like, this English sentence, right? So we'll talk to you tomorrow is the English sentence. So in case of transliteration, what happens is it writes the exact same thing in Hindi. See, will talk to you tomorrow. This is exactly the same thing written as is. It is not being translated. It is written, the same English words are written in Hindi. So for example, if I'm not comfortable reading English, but I'm very good at Hindi, so I just want to understand what is being said in English as is in Hindi. So I can kind of go ahead and read this using transliteration API calls. I can convert the English sentence into the exact Hindi words. But in translation, the exact reverse thing, I think, would say would happen. So you have will talk to you tomorrow. When it gets converted, it will tell uh, kal aapse baat karenge, right? That means it is telling it in Hindi. It's not telling the exact words as it is translated in Hindi lyric. Rather, it is converting to the Hindi language and telling. So these are the two additional things that the regional NLP language has. So it's very good to explore those APIs and tell what are the other things. So let me quickly, sorry, I just moved it. Let me quickly share the others, the demo link. Yeah, one sec. Stop sharing. Let me just stop it. Yeah. I'll quickly show you the demo that I have for Indic, and then we can quickly check. One sec. Okay. So Ranjini, can you see the note? Can you see it? Okay, cool. So this is a simple note that I just ran to show you the basic operations. So the library functions, the Indic NLP library functions are built upon PyTorch. Okay, so that's one of the prerequisite. You need to install PyTorch. Okay, so that's what I have just done, a PyTorch. So this is basically my collab node. Okay, so I've just installed that, and I have installed INLTK, Stanza, and Indic library. But if
Hey, there is a request to zoom in.
zoom in, is it? Yeah, sure. Is this sufficient? Can you see it, Ranjini?
Rashmi, I am able to see it. Rashmi, yes.
Yeah. Okay, fine. So most of these libraries are built upon PyTorch. So it is important to install the PyTorch. So that is the very first step I have done. And just to give you all a heads up, right? It is pretty easier to do pip install and all in Kaggle notebook or in Collab. You don't have much of system dependencies, right? But unlike if you have Anaconda on your laptop and you want to try this on your system, feel free to do so. So then, as I said, right, I have done a pip install INLTK, Stanza, as well as Indic. So, but we will be just using Indic. So I'm just going to scroll down and show you what I did for Indic. So this is basically the pip install for Indic NLP library, which is easily available. It's a simple command. You just do a pip install Indic NLP library, and it will install all your dependencies for that particular package. So if you want to explore whatever I have tried, you can just do this pip install. First PyTorch, then pip install, and then we directly jump to the small snippets. Okay, so as I told, right, I've done Stanza also, but that's not needed. You can just do torch and then Indic. So let us see the very first example. Okay, so this is tokenization. So as Ranjini said, right, tokenization is breaking a given statement or a document into the smallest processable subunits, right? So here we are looking at word tokenization. So because I'm just given one sentences, if you can see, right, this is the Hindi sentences. Suno kuch awaaz aa rahi hai, kaun? So it's just telling like, hey, I'm hearing some noise. Who is it? That's the exact translation I'm doing. So that's the input statement. And if you see, there is something called indic tokenize. It is a module which is present in the indic tokenize method. So you can just go, sorry, library. You can just do an import of that from this particular library. And all you have to do is just pass your input strings. It's pretty much how you do using the NLTK package, right? You will have an input statement, which is an English statement, and you just call the NLTK package dot tokenize and pass the input statement, right? It's pretty much same. You just pass the regional statement here. And because we are doing word tokenization, we will be getting one word at a time. So that's why we put a for loop, and you just print. And if you see here, this is your input statement. And if you see the tokens, right, it just gives each and every word along with the punctuation marks, because that is also considered like a token, right? So that is a simple tokenization that you can do for your regional languages. So having said that, I said there is something called sentence tokenization also, right? So I'm not going to read this big Hindi sentence, okay? So you can just read it later. This, we have 3 4 sentences here. And what we are trying to do is, here we wanted to do sentence tokenization, right? So there is a API called sentence tokenize from the same indic library. All you have to do is just use that and pass your sentence, okay? But here important thing to note is you need to mention which language you're using, right? So here the delimiter that is used for sentence tokenization is your end of statement, right? So it needs to understand that question mark, or the, in Hindi we put the straight line, right? Like full stop in English is equivalent to straight line in Hindi, right? So it needs to understand what are the delimiters for a sentence, like the ending point for a sentence in a particular language. So that's why you need to pass a language equal to Hindi. HI is the keyword for Hindi. See, for word tokenization, it is pretty simple. Okay, given any language, if you see, it is just going to take the space as the delimiter, right? See, can you see, if you can see highlighted, right? Space will be the delimiter for most of the languages. There might be exceptions which I'm not aware of, but predominantly for most of the languages, right? If you take a sentence, the delimiter to split that sentence into words will be the space. So here you don't have to mention any specifically like it's a Hindi language or a Kannada language. But when it comes to sentence tokenization, it is very important to mention that, because Hindi has a straight line, and otherwise we generally use dot in Kannada and other languages, right? So that's the reason we have mashed here language equal to HI. It's the keyword. If you want to know what are the different keywords for the different languages, right? So you can just go ahead and type indic NLP documentation in Google, and it will just show you the complete documentation. It was developed by one of the Indians, so it has a very good documentation on how to give this. So we are just passing the sentence, and here, since we have a documentation, and the output that we'll be getting after we tokenize will be one sentence at a time. So we're putting it in a for loop and just printing it, and this is how it comes, right? That is as simple as it can be, right? It's same as what you do with English language. So you can do the same thing. And there is another concept called detokenize, right? So if you see, detokenize is just the opposite of tokenize. So what tokenize does is, it takes the delimiter for a given sentence. I'm just going to talk in terms of sentence, not document, because here the example is sentence. And we know that it's going to take the white spaces and break the sentence into a small subunit of processing. That's a word. So detokenize is just going to do the opposite. So what it is going to do is, if I've given a sentence with lot of spaces and gaps, right? See, if you see here, I have a lot of gap here before, and I have a gap, lot of gap after, right? It's more like a trimming operation that we have in Python. If you people are very familiar, because this is all Python code, right? You have trim, chop, and all, where you remove extra words in the beginning and end, right? So this detokenization just does that. It kind of removes the additional spaces that is there in your given input, and just makes sure that you just have one white spaces for sentences. So here, if you see the sentence, if you clearly notice, right, a lot of couple of white spaces in the beginning, end, and before comma and all, right? So this is your input statement. So when you do detokenize, right, it gives you a more formatted statement with just one space between the words, right? So that is kind of detokenize. So if you feel your script that you're processing is kind of not having a lot of white spaces, you can kind of just do a detokenize before you do the actual tokenize and split the sentence into word. So that is one good library to explore. And as I mentioned in that diagram, right, transliterate. So what is transliterate? It's just going to take a given word or a sentence and convert it into another language dialect, but keeping the word as is. I mean, if you see here, the input string is Rajasthan, right? So the output is Rajasthan only, but it is written in Kannada because I have told my input string, the input string format is Hindi. I want the output of this in Kannada. Don't convert the meaning of that into Kannada, but write the word as is in the Kannada lyrics, right? So in the Kannada script. So that's how it is written. It is written the same word as is. It is not translated it, rather it is transliterated it, right? There's a minute difference. So that is one interesting thing that you can just explore. So you can just play around, right? You know, you can give Kannada sentence, Malayalam sentence, and you can see whether how it will be written in English or Hindi or Gujarati, right, or Telugu. So it's like just you can explore how to do these things. And the another one is like, see, for example, I have a word. Okay, it's Palakkad. It's generally a Malayalam word. That's why the language is ML. Okay, ML Malayalam. So the input is Palakkad. It's not written in Malayali. Okay, it is just written in English only. So we just want to know what is the exact Unicode for this in English if I take it, right? So why do we generally need this? Is sometimes when we are processing, right, we need to encode this strings in a specific encoded format, right? And when we encode it in that specific format, the processing becomes easy rather than taking the string as is, right? Before doing all the pre-processing, we encode the string in UTF-8, UTF-32, like that. So when sometimes we're working with NLP, regional languages, right, it is nice to unicode that language in a standard format and then process it. Depends on our use case. So for that processing, you can use this Unicode transliterate, right? So it has translated the Malayalam into the Unicode numbers and listed over here for each of the character here, right? It has listed the corresponding Unicode, and then it is easy for us to process depending on our use case, right? So that is one thing. And this is another example for transliterate from Hindi to Telugu, how a sentence can be translated. And Ranjani did touch base upon the n-gram, right? So if you take any language, right, there is a probability that the word if you take English, New Delhi, the probability that New and Delhi will occur together is very high because it refers to one place, right? New Delhi is one place, but they're two different words, but they co-occur together, right? So if you want to figure out what is the probability that two words in a given statement occur together, right, you can use n-gram kind of processing to figure that out. So that is what they have here. This simple code does. It takes in Hindi statement the same thing, that suno kuch awaaz aa rahi hai kaun. um, so once that statement is taken, we do a simple tokenization here, okay, where we split that entire sentence into small words. Then after we do the pre-processing, we are checking if there are any stop words. Okay, stop words are like the exclamations and all the other things. So we do a pre-processing for the stop words, we remove the stop words. After we do the stop words, we are doing the n-gram here. So we are trying to do n-gram in terms of telling the frequency of, when I do n-gram, I can pass n as number of variables. Okay, so when I pass n as 1, it basically gives the frequency of the word in the entire document. Like I tell suno kuch awaaz aa rahi hai kaun, right? So suno has appeared only once. So when I do 1 gram, right, it will just tell me the frequency of each word in the sentence. Suno 1, kuch 1, awaaz 1, aaj 1, Rahi one, Hey one, and Con one. Okay, so it's just going to tell me that 111 frequency. That is 1 gram. Generally, people don't do it. They do it if they want to know the frequency of word in the given document. Here, the frequency is 1. Suppose I had this statement 2-3 times, like suno kuch awaaz aa rahi hai, Con. Aapko awaaz suna kya? So awaaz is repeated 2 times, right? So that time, if I do 1 gram for this statement, two statements, then ours will have 2 as the frequency, right? So basically it is used for frequency count. But if you take 2 gram, right, 2 gram will actually tell you the frequency or the probability with which two words can occur together, right? So if we see here, we have done the engram over here, and kind of printed, see, it has given you the word for suno with a comma, right? The frequency is just once, it has appeared only once in my document, right? And comma with kuch. So it has, if you like look at the statement, right, all the combinations like this have appeared only once in the statement. So in your input statement, no combination has appeared two times, right? If I had a two statement, and if it's like rahi hai is repeated again and again, then the frequency of those two words occurring together will increase with the number of time they occur in the sentences. So since here all the occurrence is one, so the two words that are considered at a time, they are considered as one. So that is one good example to explore. And as I said in that one more thing, right, the each of the languages have their own different pronunciations, right? So if you have one word, one character, it could be as small as a character, so you can try to understand whether it is a vowel, whether it's a consonant, whether it's a velar. So these velar, palatal, and all that, they all depend from which section of your throat you are telling that word, right? When you take regional languages, when we are in school, teacher tells, you should tell na. They're two different things, right? To understand when you're processing regional NLP, a given character, with what exactly is it, to process it in the right way, right? Like we have definite articles in English, like that in Hindi also we have, right, like the and all that equivalent in Hindi. To understand all that, you might want to use these libraries. So these are some of the sample examples that I quickly could tell and share with you. So over to you, Ranjini, to do the stanza and the other one.
Sure, sure. But there
So
is a
I'll
question how
just,
to get
yeah.
Hindi words in the string. Just a clarifying question. Is it about separating Hindi words from English text, or okay, okay, if you can clarify, we can answer it.
Yeah, I will take it over the
Yeah,
chat,
sure.
Ranjini, for the
Yeah.
benefit of time. Yeah.
Yes, yes. So Ramya has spoken about all the Indic NLTK library capabilities, and I will show you some of the capabilities of INLTK and Stanza library. If you can see my screen, please let me know.
It's just loading, Ranjini.
So, are you able to view the Kaggle notebook that I am sharing?
Yeah, probably you want to zoom it, Ranjini, like last time. With specs
Does that
also, I'm
help?
not able to see, guys. uh,
Even now?
little, yeah, great. Thank you.
Sure. So Ramya used Google Colab to show how you can quickly, without even setting up the backend environment, you can start coding and try to look at the results. Similar to that, there is this Kaggle environment. If you go to kaggle.com and you want to execute the code, that is also possible. So I'm showing this kaggle.com where I have tried to use the INLTK and the Stanza library and code and show results for it. In the interest of time, I have my code executed and I will show the results. So for having INLTK, we would need Torch, as Ramya also mentioned. Torch is a prerequisite. So I have installed Torch, and it is as easy as doing a pip install Torch and one statement. So that has gone and got my Torch library from the internet, and it is there in this environment for usage now. So the next step is to install INLTK, which is the library of interest for us now. We are again doing it in a step easily with pip install INLTK, and this notebook will now be able to use INLTK, import INLTK and use the functionalities. So, so the initial set of steps had been explained by Ramya. So I expect that all the tokenize and parsing of the sentence and understanding the meaning, stemming, lemmatization, and all those could be taken care by the Indic NLP. And this library INLTK has specific capabilities to identify languages. So, as Ramya also mentioned, it has support for various regional languages like Hindi or Malayalam or Tamil or Telugu or Kannada. So, we will first have to set up which language out of the existing models we are going to try and use for our use case. So, if I have a set of text that is in Hindi, I will first set up the model to load all the Hindi related models and learn based on that Hindi related models, and then try to interpret whatever input text is. So for this, in this case, I am doing importing all the required classes from the Python module INLTK, and then the first step is I am doing a setup of Hindi. So I'm telling that I want to process Hindi text now. So please ignore all the errors that are there. So it had happened while running the command for the first time, but you see that the model has been downloaded successfully, and it is available for usage now. Now that the INLTK model is already available, we see that we can send a Hindi sentence to this as input and try to understand what the tokens are. So for example, this tokenize method, when used on a sentence or a set of text, what it will do is it will split into words and tell number of unique words that were present in the sentence, and also help to show that the list of words that were present in the sentence. So this is something that is already covered, but what is unique is about getting the sentence similarity. So when you have to compare sentences, like how similar is one sentence with others. So I say that in this example, I say that Bharat ek adbhut desh hai, and we say Rishi Muniyon or Avataron ki bhumi Bharat ek sahasyamaya desh hai. So we say that these are two sentences. So we both are talking about Bharat, but how similar are those sentences and the meaning that is conveyed with each of the sentences, that can be got as a number with this get sentence similarity. If you see, so when you have spoken good about Bharat and in the next also there is something good about Bharat, you see that the similarity score is more. In the same case, if you give some varying sentences, you will get a lesser similarity score. So in that way, you can understand how similar these sentences are, and also try to use it in various applications to find out the similar sentences and the passages, to understand the complete passages, etc. All those can be done using this get sentence similarity. So that is a unique ability of this INLTK. And the next ability is to predict the next words. So this may help in language generation. Once you have given a question and after understanding and interpreting the question, you have to form the answer, right? So for example, if you in the previous example where I told about the question typed in the chat bot, what is your return policy? So after understanding what the question is and understanding the intent of the question, we have to frame the answer. So this predict next word can be used in such context. Like you have the question, you have read the question, and you are trying to frame what the answer would be. So for example, this is all done with the model that we have built and the corpus that has been given to the model. By corpus, I mean the text chunk or the sample text which has been provided to the model. So this INLTK models have been built using some of the text, Hindi text. It has learned from the Hindi text, and based on that, it is trying to predict the next set of words that can be coming after this sentence is given. So when I say predict next words and Bharat ek adbhut desh hai, and I say give me some 10 words that can succeed this sentence. So give me the 10 words that can be told after this sentence based on your learning. So that has written Bharat एक अद्भुत देश है, and जिससे भारत को विदेशों से मिलने वाली पहचाना. So even though I don't understand English, Hindi better, I can see that it is giving something in relation to Bharat and saying how it is different from other countries or those just by the word Videsha. So this is how you can generate sentences using this library. So those are some of the unique aspects of INLTK. You can also find out the language of a sentence given using this INLTK. When you give, when you use the method, it would return, when I say Bharat ek adbhut desh hai, it would return answer as Hindi. And if you give any Malayalam sentence also, it will return as Malayalam. So this is how the INLTK would be used in various use cases. So there is also the Stanza library or the Stanford NLP library that we talked about. So coming to the Stanza library, it is also as easy as installing pip install Stanza, and you are there to use the Stanza method. So in this example, I am using the Stanza pipeline. So to mention what all should be processed with the text that I have provided. So I want to tokenize, I want to do the lemmatization, I want to do POS tagging, parts of speech tagging, and I want to do dependency parsing. So I have mentioned what all tasks have to be done through this Stanza pipeline, and then I am going to apply this into the text that I am providing as input. So for example, if this Bharat ek adbhut desh hai is given to this pipeline, this Bharat ek adbhut desh hai would be tokenized first, and all the stemming and lemmatization for finding out the root words which give distinct meanings are done, and then it is identified whether it is a noun or a verb or adverb or adjective and all the parts of the speech. And then we also see the dependency parsing. So which word is related to which other word in the sentence. So I have taken this and started the configured this pipeline method, and then I am asking to give the output of all these processes that I want to do. So from the sentence that I have given, we see that in the beginning, the model is first downloaded, and then the pipeline is built to see which functions have to be executed. So we see that there are the tokenization has created all the individual words, has separated out all the individual words, and it has given that as a output. So you say Bharat is a word, Ek is a word, Adbhut, Desh, hai are all separate words. And we also have the parts of speech. So this is Bharat is a proper noun, and what this Ek, it is a number, and Adbhut is an adjective, and noun is Desh, and hai is some auxiliary word. So we see that this parts of speech tagging is also done. And we also have done some of the lemmatization, like Bharat is a unique word, and when you get the lemmas out of it or the root words, that also gives Bharat only. And it is also telling about the proper noun, and all details about that is given. So this is how you can use to understand and show the various tasks that can be done using the Stanford NLP library. So as I mentioned, this is a basic step. Using this, we can build a lot on top of it. As I said, after understanding the text you can generate, and you can try to build a chatbot and all. Once you have understood why we are doing these, the coding is more of uh, less lines of code that you have to do to get the things executed. It is more important to understand the building blocks of the solution itself. Hope we were able to give some details on those building blocks.
Sure. Hey Ranjani, just we'll show that last slide for them and just end the talk on the
Yeah,
open
sure.
source tool by Google. Yeah. Yeah, so just to end our talk, folks, we have this last model that we've just wanted to tell you. It's called Mural. Okay, it is by Google. It is a multilinguistic representation for Indian language. So, if open source is something of your area of interest, you can definitely check out this tool. It is when I tell tool, it's more of like a library, just like the three libraries that Ranjay and I spoke about. This is one of the other library, which is an open source machine learning library being developed by Google, and there's a lot of scope for research in this. So feel free to explore more of this. Due to the shortage of time, we're just stating this model. So this is one of the upcoming hyped out models, so you can explore them. Just type in Google and you'll get wonderful papers and articles about it. Yeah, hope we were able to give you some insight. Please take this session as a good place to start exploring regional NLP, because we need a lot of researchers in this domain. Thank you. So I hand over the stage to Madhumita, and I'll stop sharing.
Am I audible?
Yeah.
Okay. So that was really a great one, Ramya and Ranjani. I thank both of you for your time and sharing your knowledge. And it was great explaining with good illustrations on how NLP is used today's world and how to make machines respond the way a human would. So that was really interesting. And you did not just enlighten us with the technical aspects, but also helping us understand the importance of how we could apply our skills and knowledge regionally, to empower people even. And I'm sure everyone had grateful insights from the session, and this will surely help us inspire each other and grow together. Thank you so